Hello guys, my name is SHIVAM HIPPALGAVE. I'm from A division. My roll number is 37. My PRN is 2023010400046. And today I'll be explaining my CG computer graphics project, which is a solar system animation which we can control using our joystick, our keyboard buttons. I'll just show you the project and then I'll proceed with explaining it. So this is my project where we can control it. We can zoom in, zoom out, then we can see all the planets rotating. We can change the viewing angle, by what angle we have to view it. So this is the project. Now I'll explain you with the code. Uh, the code is divided into 5 files: main.cpp, solar-system.cpp, HPP is stars.cpp, and that's HPP, which contains class. So starting with main.cpp, the file serves as an entry point for the solar system simulating program using OpenGL and GLUT. Here's a breakdown for that. So this GLUT.hp includes the GLUT library for handling window management, input, and OpenGL setups. This solar system.hpp includes the header file for the solar system class, which likely handles all the solar system related logic, including drawing planets and simulating movements. And then coming to these are macros. These macros set the initial position for the, and dimension for the windows. And coming here, some global variables. So this solar system, for solar system and stars. So coming here, we created a function on display, and this function registered in GLUT to handle the display of the solar system. And the second function, this function called continuous. This function is called continuously in background, allowing the simulation of update even when the user isn't interacting with the program. So and coming to the on keyboard event, this handles the keyboard events, when we press the key XYZ, when we want to change the angle, pass through the key press along with the cursor and Y coordinates, key and xy coordinates. So this is the main function. This main function initializes GLUT, then sets the display mode to RGBA, then sets the starting position of the window, sets the initial size, creates window, and displays the function which we created above, and handles on update function and on keyboard function, and finally display GLUT window, which loads our screen continuously. So coming to the second file, uh, which is solar-system.cpp. This file contains the implementation of solar system class, which handles the core functionality of solar system simulation. Here's a simple explanation for the each part. So these parts, these are the constants for position of camera and resets. So this function creates some parts which I'll explain. So this is what clears the color and depth buffer for and prepare for the new frame. This sets the background color for the dark gray. This sets background color to dark gray. This is a projection setup, from where we resets it, and the other is view setup, from where we have to view it. This is lighting and depth testing, where this is GL enabled, and GL depth test. These are all the lightning tests, and the solar system on update works here, and the another is camera movement. So solar system on keyboard. So this handles the keyboard press keys which we enter. And there are for multiple keys: W, S, S, small s, capital S, A, D, X, and R. So these all have the task which is assigned, whether zoom in or zoom out. And this stars, these are all the macros, the width, how much they will be separated from each other, how much what will the speed and etc. Everything is decided, the radius and the speed, which you can see here. This is the enumeration of which assigns the essential body and unique integer. Um, the finally and lastly, solar system constructor. This is the construction which initializes solar system camera position and essential bodies to each of it. So the first one is camera position, second is creating celestial bodies, and the lastly the destructor, which is called after the execution of program. So this was about solar system. Coming to the HPP file. For this header file, HPP defines the interface for the solar system class, which is part of the solar system simulation. These are preprocessor derivatives. These are the header files which we includes, and these are this is a macro which we define star num as 10. In this class definition, the solar system is a class. This solar system constructor which initializes solar system and sets up initial position of essential bodies, this one. And this is a destructor which cleans up the memory used by the star objects. On display this method that handles rendering solar system on the screen. Then this on update method updates the simulation, etc., moves the planet. And on keyboard event handle the keyboard changes. And the private part, this pointer star now. This is an array of star pointers where each star represents a celestial object in solar system. The array can hold up to 10 star objects corresponding to 10 objects. That's why we give that 10 number. This is a GL double, which are the views like view x, view y, view z in our 3D space. GL double, this center x, center y variable in the space. And these are up x, up y, and up z variables for our up vector and camera, for up vector of camera. Coming to the next file, stars.cpp. uh, so stars.cpp file contains the implementation of star, planet, and light planet class, which are central in the solar system simulation. These class models class model celestial objects, stars, planets, lights. This file method for drawing these objects in OpenGL. So I'll start with explaining the code. These are preprocessor directives includes, and this is the macro defined pi, and the star.h for the header star.hpp is also included, which likely declares star planets and star planet classes. I'll show you that later. The CMath library is included for function like cosine and pi. So coming to the part here, star. So this is a star class implementation. So the constructor initializes a star object with a parenthesis like its radius, distance from the sun, rotation speed, etc. Then this RGBA color 4. The RGB color 4 star is initialized to height 1.0 f floating point. Then the parent star points to the star's parent, example the sun of the planet. The speed is converted into the rotational velocity. If the speed is greater than the zero, it's calculated as 360.0 f speed to determine how fast the star rotates around its parent. Otherwise, the speed is set to zero. Coming to the method. So this is a GL. So GL enable GL line smooth, and this enables line smoothing and blending for better rendering. This GL push matrix and pop matrix. This push pops the matrix starts to preserve transformation. GL parent star GL parent star transform. Its star has a if the star has a parent, it rotates and translates to the parent's position. The rotation is based on parent's angle alpha. Then drawing the orbit and self rotation track what it does. And coming to this part, the update, which is the update method which updates the rotation angle of the star. Alpha orbiter angle is updated based on the time span and speed, while alpha self rotation is updated by its self speed. Coming to the next part, class implementation. The GL class planet inherits from stars and represents a planet in the solar system. And this part, draw planet method. This method sets OpenGL material properties for the planet, including ambient, diffuse, spectacular, and emission components. The planet's color is applied to the emission. So this is what everything is done here. And coming to the next method, light planet class implementation. Light planet class constructor. This is a constructor basically which calls the planet constructor to initialize the properties of the planet. There are no additional changes here. And lastly, draw light method. So this method sets OpenGL lightning properties to light emitting object. Light is position at the origin, and the ambient, diffuse, and specular components are set to the light source. Coming to the last part, stars.hpp, which is our header, of course, for which we created for stars.cpp. This header file represent the cell-scale bodies, star planets, light emitting objects, 3D environment, etc. So the starting with class declaration. Star class represents stars like radius, distance, speed, self-speed, etc., which means a star might orbit around another star. Then parent class inherits from star and represents a star which also has a color and other characteristics, including its own drawing method. Inherits from planet and represents a planet that emits light, such as moon or other light-giving object. Mm, Then the method in stars, which has constructed initializes the star's object with radius, distance from its self speed, and pointer for the parent star. Then draws the star in 3D space. Updates angle alpha based on the time passes and rotating over the other time. Draw a virtual function. This function implements the draw star. So this is what it done. And the method planet, what does is it initializes the radius, distance, and self speed as well. So and lastly calls the draw planet and draw star rendering bodies. And last class light planet. So this inherits the light planet constructor, as we can see here, and creates a light emitting planet. Sets the lightning properties to light emitting planet using OpenJS lightning system. So this was all of it.
So hello everyone, today I'll be explaining the code for the particular scene which you can see on the bottom of the window. The upper side contains the code and the below window is basically a loop of the scene which we've generated. So as it's visible, this particular scene is of a smart city or a high-tech city with almost all facilities like greenery, well-built infrastructure that includes food court, residential building, hospitals, etc., along with public transport facilities such as buses, on which translation is also applied, so they are moving. Now I'll be moving on to explaining the objects which are present in this particular scene. The first ones being the trees. A few of them are curated using the circle function and a few of them are created using simple lines. There are buildings which are present and multiple of them. A few buildings represent food court, some represent residential buildings, some represent hospitals. Then there's the road and then there's buses moving. There's sun, clouds, and then the background is basically just the sun, the sky. Also, when I'll be scrolling through the code, you will notice that comments have been provided at particular steps for others to determine what part of the code, that like what segment of the document refers to which part of the code which is rendered in the final image. Now before I move on to actual explanation of each segment of the code, I would like to highlight that all the objects which are present are rendered solely using OpenGL function. No forwarded or direct functions have been used to create any of the objects. And now we'll start with the actual explanation of the code. This particular scene has a lot of buildings, that is there are almost 6 buildings. So the reason I'm skipping through the code is because all of it includes the same things. The buildings are made using GL quads. Also, if you check out the commented parts, it's written first building, 5th floor, second building, main part. It basically, what we've done is that each building and its code is written floor wise, and then their positions have been determined using GL vertex function, and specific color codes have also been determined for each building. That's it for the buildings part, and the road which you can see on which buses are moving are created through GL lines functions. Also, we can see buses. The buses are again created using GL quads. The windows also through GL quads, and the circular part, that is the wheels of the buses, they are created using void circle function, wherein there are 4 parameters to be passed: Rx, Ry, Cx and Cy. Which are basically the codes of the coordinates, radius, and the number of num segments which are required for creation of the particular circular image. Now moving on, I will try and explain why there are characters such as hospital, food court, DIU, and even EDU is present on the buses that are moving. How we've incorporated these characters to be displayed on the particular scene. So All of this is possible due to the use of functions, two functions basically, GLU bitmap character and raster position. Now moving on to explaining the functions of both. The GLU bitmap character basically helps us in determining the character which is to be displayed on the screen. The GL color 3UB determines the color of the particular character which is to be displayed, and GL raster position basically defines the position of that particular character on the screen, that is where it will be rendered. For example, from this code we can determine that the character D will be represented at the position 416,270 on the particular screen. That is it for this particular code. I hope you were able to understand. Thank you.